So you want to achieve centralized logging, and you've probably heard of Fluentd. Now Fluentd is a fully open source log collector that allows us to collect logs from many sources and send it almost anywhere. So welcome to another video about logging. In this video we're going to be taking a look at the fundamentals of Fluentd, how to run it, how to configure it, and how to collect logs from various sources and push it to a central place where it can be analyzed. The Fluentd documentation is a great place to start. The first thing we need to know about Fluentd is the concept of input plugins. There are various types of input plugins that help us to get logs. So number one, where do we get logs from? This is what input plugins are for. You may have a web server writing logs to a file, you may have applications sending logs to standard out or to an HTTP endpoint. You may also have many containers that write logs to standard out. So in this demo, we'll take a look at three popular input sources on how to collect logs. The first one is a web server where you might have application that is sending logs to a file. This is very simple because we can install Fluentd and configure it to collect the logs and send it elsewhere. The second example is having an application that uses code logic to send logs to an HTTP endpoint. This is useful for scenarios where you cannot have Fluentd installed, like a cloud service. And then the third option is collecting logs from a Docker host where you have multiple containers running. So before we start running applications, let's understand input plugins. So to read logs from a file, we're going to take a look at the input plugin called tail. And all input plugins are defined by a source block. So if we take a look at a Fluentd configuration file, we have a source block and we say what type of input plugin we want to use. We say tail. We tell it format JSON, meaning that we expect our logs in JSON format. Read from head true means that Fluentd should start from the top beginning of the file. We also tag our logs. This is very important when we want to use post-processing and tell Fluentd where to send the logs. We will use tags to identify the logs we've collected. So in this example, I'm saying file-myapp.log since I'm going to be running an application that's writing logs to a file. We also tell it the path of where to collect the logs. So our application will be writing a log to this location. We also give it a position file. This is the file where Fluentd will track up to which line it's read so that it doesn't start from the beginning. So that's the file-based input. The next input source we're going to look at is the HTTP input. This is useful if you have an application or web server where you cannot install Fluentd and you can write some code to send logs to an HTTP endpoint. So that is the HTTP plugin. Now for that we have another source block where we specify type as HTTP. We give it a port of where to expect logs and the address to bind to. We also provide a body size limit of the logs and a keep alive timeout to keep the connection open. So now that we have various sources, we can collect logs from a file, from an HTTP endpoint, from TCP and UDP and other Fluentd instances and various types of inputs. But once we have these logs, what do we do with them? This is where output plugins come in. Input plugins use a source block to define where to get logs. Once we have the logs, we need to do something with it. Output plugins allow us to do almost anything with the logs, like dump it to a local file, forward it to another Fluentd instance, send it to another HTTP endpoint, send it to Kafka, S3, CloudWatch, databases, Elasticsearch, and more. So where input plugins uses a source block, output plugins will use a match block. So in the match block, we're going to have to match a specific tag. That's why it's important in the source block to specify a tag so that we can then match that tag in the match block. Now you may have multiple incoming sources, so it's important to match the tag correctly. So there are various types of output plugins such as file, forwarding to another Fluentd instance, another HTTP endpoint. There are also output plugins to send logs to S3, Kafka, and Elasticsearch. But before we take a look at those complex ones, I highly recommend when starting out with Fluentd is start with a simple output file plugin. That way you can collect all the logs and test whether your sources and tagging works and just write it to a local file. So for that I have a match block here where I'm going to pick up my logs from a file and the type of output plugin is set to file and I specify a path. This is the path where Fluentd will dump all the logs it collects. So the Fluentd tail input plugin will read logs from a file and tag it. The output plugin will then match the tag and write those logs to an output file. Now it's important to note that these inputs and outputs are called plugins for a reason. That's because Fluentd has an extensive plugin capability. So if you want to send your logs to a specific location that's not in this list, check the documentation because it's highly likely that there is an external plugin capability that you can install. So enough about the theory and the documentation, let's dive into the source code. So in my GitHub repo, I have a folder called monitoring and logging, and in here I have a README guide for the whole logging series. In a previous video, we've taken a look at the logging basics, spoke about standardized and centralized logging, and in this video, it's all about FluentD. So I have a FluentD folder, and in here I have another README. In this README is all the steps that I'm going to be showing you today. So be sure to check out the link to the source code so you can follow along. So let's say we want to read logs from a file of an existing web server. So for that example, in my monitoring logging FluentD introduction folder, I have a Docker Compose file with various services. So for this example, I have a service called file my app, which is basically an Alpine container that runs a little shell script. So if we take a look at the file folder, in here I have app.sh, which is going to run a loop that just writes logs in a JSON format to a file. You can also see I have the example log here. This is the file that it will be writing to, and it will be appending to this log file. Now this could be representing a web server like an Nginx or an Apache server that's configured to write logs to a file in JSON format. So to run that application, I'm going to change directory to the FluentD introduction folder. I'm going to say docker compose up -d, and I'm going to run the file my app. That's going to go ahead and start up the Docker container. I can say docker ps and we can see it's running. And if I take a look at the example log file, we can see it's starting to append logs in JSON format here. So now that our application is writing logs to the file, how do we collect those logs? So if we go back to the Docker Compose file, we can see I have another service for FluentD. So in this file, I say container name is FluentD. I want to run the FluentD image, and I'm going to create a few volumes to mount files into. The important ones in this example is the file folder. This is the file folder we have on the left here where our application is writing logs to. And the other important one is the configurations folder. So I have a configuration folder with a FluentD configuration file. We mount that file into FluentD/etc. That is the default location where FluentD will pick up its configuration file. And if we take a look at that configuration file, we have the source that I showed you earlier. Source is type tail. It's going to read basically logs in JSON format. It's going to start from the beginning. It's going to tag all these logs with file-myapp.log, and this is the path where it's going to pick up the log. That's because we're mounting that log file, the file on the left here, we're mounting into FluentD log files example-log. And we also have a position file so FluentD can remember where it's read up to. So we're going to take all these logs from the source and we're going to match it with the tag, and this is the output plugin. So in the output plugin, I want to test whether my source works. So I'm going to just use a basic type plugin called file, and I'm going to write it to an output directory. And if we go back to the Docker Compose file, you can see I'm also mounting that output directory here. So there's another folder that's currently empty. It has a placeholder, and this is the location where FluentD will dump all the logs. So to start FluentD in background mode, I'm going to say docker compose up -d FluentD. That's going to go ahead and start up FluentD container. And if I say docker ps, we can now see we have FluentD up and running, and we have our application that writes to file. So FluentD should now be picking up all these logs, and we can see that is happening if we take a look at the logs folder that we mounted in. This is the output directory. We can already see that there's a folder created called file-myapp.log, and FluentD has started collecting all the logs in here. Now that is the tail plugin example in action. Now this is useful for collecting logs from disk, but there are some rare occasions where you cannot install FluentD on the server. Sometimes your application is running outside of Kubernetes or outside of your own systems where you don't have control to install stuff. So you may have no alternative mechanism of getting logs out of the application. So for that example, let's take a look at the Docker Compose file. I have another small application called http my app. This is running a basic Alpine container image, which is mounting an HTTP folder, installing curl, and running a little application's shell script. And if I take a look at that script here, it's basically running a loop, and every 5 seconds, it's sending logs using curl, sending logs in a JSON format to the FluentD endpoint. So this basically simulates you having an application where you have a logging library installed, and your application is sending logs out directly to FluentD. So to start that application, I'm just going to say docker compose up up, and I'm going to say -d and http my app. That's going to go ahead and start that up. I can say docker ps. We now have the HTTP application up as well as the file application. And if we jump to the fluentd configuration file, let's take a look at how that is set up. So I have another source block here where I say type is HTTP. I tell fluentd to listen on that port, bind to this address, and this is the body size limit of the messages and a keep alive timeout to make sure I'm not creating a lot of connections and I'm reusing those connections. I then specify a match block where I match the tag, and you can see here I'm using a wildcard in this example. So I can match the tag that's incoming and I write it to the output folder. And if we take a look at the output folder over here, we can see that there's already an HTTP log of all the logs that fluentd has collected via HTTP endpoint. And we can see all the logs are being collected and written to file here. So another useful feature is called filters. Now filters is basically a post-processing pipeline where you can pick up logs and then you can do stuff with the logs before sending them to an output plugin. Now a filter looks very similar to a match. It allows us to do various different types of filter capabilities. So let's take a look at a filter example. So I have my source collecting my files logs, and before I send it to the output plugin, let's do something with that log. Now a filter block looks pretty similar to a match block where you can match a specific tag, and it also has various plugin capabilities. So in this example, I'm showing you the record transformer. So you can do stuff with the log record. So here what I'm doing is I'm basically injecting a host parameter field into my log. So I'm taking the host name of the server and injecting it into the log before sending it to the output plugin. So I'm going to add that for the file logs, and let's do the same thing for the HTTP log. So I have the source here. I'm then going to inject a filter over here using the same tag as the match block, and I'm also going to transform this record and insert the host name of my server. This is useful to understand where the logs are coming from if you have multiple servers running behind a load balancer. Now to make that change, I have to restart fluentd. So I'm going to say docker compose restart fluentd, and that's going to go ahead and restart it. Now if we go back to the output area where the logs are being dumped, and I open up one of these buffer files and I scroll to the bottom, I can see that fluentd is now injecting the host parameter that we've specified. So the host name of our containers, and this is the host name of our container image, which is the container ID. So that is how filters work. fluentd also allows us to structure our config to make it easier to read and less complicated, and this is done using the include syntax. So to break apart our fluentd config into separate files, you can see we have two parts of our config here. We have this big block here which is related to reading logs from a file and writing it to an output file, and we have the section here which is related to reading logs from an HTTP endpoint and writing it to a local file. So let's start with the file part here. So let's create a new configuration file called file-fluentd.conf, and let's take all of this stuff that we have over here and paste it into that file. And now that we have all of that stuff in this new file, we can go back to our fluent.conf and we can include that file saying @include file-fluent.conf. We can then go ahead and take this block out, so we can create another configuration file called http-fluent.conf, and we can take this block out and paste it into the new file. And then we can simply refer to that saying @include http-fluent.conf. So you can see my configuration file is now quite neat, easy to read, and well structured. Now let's say we have a machine with Docker on it with a bunch of containers running, and how do we collect all the logs from these containers? Now I'm going to show you a simple method in doing so, and this is the same methodology we'll be taking a look at in a future video when we run fluentd inside of Kubernetes. Now to read container logs, let's create another configuration file, and this time we call it containers-fluentd.conf. And in this file I'm going to add a new source to tell fluentd how to grab container logs. Now collecting logs from containers with fluentd is very simple, and the same concept applies to Kubernetes when running fluentd as a daemon set. If we take a look at our docker compose file, I have fluentd, and I have a very important mount point, which is var lib docker containers. This is the folder of the Docker host where Docker stores all container logs. So we're going to mount this into /fluentd log containers. And if I go back to the containers fluentd conf, we can see I'm using the same concept of the tail plugin I showed earlier. I also expect format JSON because Docker writes writes its logs in JSON format by default. Read from head true. We tag it this time as docker.log, and this is the path where we mount in all the Docker host logs. So that's being mounted into /fluentd log containers, as I mentioned in the Docker Compose file. And we put a wildcard here because this is the folder structure that's going to have all the container IDs and then the container ID -json.log. And then we also specify a position file so fluentd can remember where it read up to. And then finally here we specify a match block. As I've specified before, we say docker log, and we're going to match all those logs coming from that source and write it to output. And to include that config file, I'm going to go back to my fluent.conf and I'm going to say add include containers-fluent.conf. That'll keep our config file very well structured. So we're now collecting file logs, HTTP logs, as well as Docker container logs. And to kick off that change, I'm going to say docker compose restart fluentd, and we can immediately see in our output folder here, we now have a docker.log. This is the tag of all the container logs. We can look at the buffer, and we are now picking up all container logs on this machine. To showcase this, I can say docker run -it redis to start up a Redis container. You can see the logs are written to standard out. And if we give it a minute and we go back to the docker log buffer of fluentd, we can see that fluentd has collected all the Redis logs. So now that we know how to collect logs from different sources, you're probably thinking, well, I don't want to write all these logs to a local file. You want to push it out to S3, Kafka, Elasticsearch, CloudWatch. So to achieve that, I'm going to show you how to send log externally. Now, fluentd has a very extensive plugin system, and it also has an Elasticsearch plugin, which you can see over here. So for this demo, I'm going to go ahead and I'm going to install the Elasticsearch plugin. Now for that, I've created a simple Docker file over here where we say from fluentd, we pick version 1.11. I switch to root user so that I can install the plugin. I install the plugin using gem install, and then I switch back to the fluentd user. If you take a look at my Docker Compose file, I've also specified a build context and an image name. So I can just say Docker Compose build fluentd, and it'll go ahead and build automatically. Now to send logs to Elasticsearch, let's go ahead and create another configuration file called elastic-fluentd.conf. Now in this config file, basically what I want to do is have 3 match blocks, one for each source. Since I have a file, an HTTP, and a container source, I want to take those 3 sources and send the logs to Elasticsearch. So I'm going to go ahead and create 3 match blocks, each of them matching their respective tags. So this one is for the HTTP logs. I say match http-star.log, and I say type is Elasticsearch, the host name of Elasticsearch, and the port, as well as the index in Elasticsearch to write to. Now Elasticsearch has a concept of indexes, so you can write to different indexes. I'm creating an index per source, so I have index name here is fluentd HTTP, and the type name is fluentd. I then specify a second match block, which is my file application, the application that writes to file, and I also have the same Elasticsearch details here, and in this index name I have fluentd-file with the type of fluentd. And then the final match block is the Docker log, so all the container logs come to this match block. I have the same Elasticsearch server specified here. I also have an index name called fluentd-docker. Remember, you can specify these index names and set up the indexes any way you want. So to use this config file, I'm going to go back to my fluent.conf, and I'm going to include elastic-fluent.conf. And this configuration file basically sends all logs to Elasticsearch. Now, because we're sending our logs to Elasticsearch here, we may want to stop sending the logs to the output file. So in the file fluent.conf, I'm going to go ahead and I'm going to remove the match block. I'm just going to comment that out. I'm going to go to the HTTP conf. I'm going to comment out that match block, and I'm going to go to the containers file, and I'm going to comment out that match block. We want to make sure we're not writing it out to the local file and prevent it from hitting Elasticsearch. So I've commented all that out, and now Elasticsearch config file will take an effect and send all our logs from the 3 different sources we have here to Elasticsearch. So now that fluentd is ready to send the logs to Elastic, let's start up Elasticsearch and Kibana. So I'm going to say docker compose up Elasticsearch Kibana, and that will go ahead and pull those images and start up those 2 services. And now if I do docker ps, we can see we have Kibana and Elasticsearch up and running. Now it may take a couple of minutes for Kibana to start up, so just be patient, and then head over to localhost 5601 to access Kibana dashboard. And because we've made those config changes, we want to be sure to restart fluentd. So I'm going to say docker compose restart fluentd, so those changes start taking effect, and we should see logs being shipped shipped to Elasticsearch. So what we want to do after a few minutes is head over to the menu, say Discover, and you'll get to the index patterns section. And to see when log starts coming through is we're just going to type in here FluentD, and you can see nothing has come through yet, so we have to be patient. So in the index pattern section, I type FluentD and I say create index pattern. We can see that there's no logs yet, so we have to be patient and just click this button until logs start coming through. Eventually you'll see it will start coming through, and now we can start to type an index pattern. So I can go ahead and say something like fluentd-star, and we can see we have 3 indexes here. Fluentd Docker, these are our container logs, we have our file application, and we have HTTP endpoint logs. I can then click next, create index pattern, and head back to the discover section to start looking at logs. And now you can see we have this area where we can query our logs, and we can see all our logs are being shipped to Elasticsearch. So it is all good and well, all working nicely. So I hope this video gave you a good fundamental understanding of FluentD and how to configure it, and how to pick up logs from various sources, and more importantly how to send logs out of the system. Now in a future video we'll be taking everything we've learned, and instead of running a local container we'll run it all on top of Kubernetes. So we'll take a look at how to achieve centralized and standardized logging in Kubernetes ecosystem. So be sure to let me know down in the comments what sort of logging videos you'd like me to cover in the future, and also be sure to like and subscribe, and stay tuned for the next one. Remember to check out the community link down below, and if you want to support the channel even further, be sure to hit the join button to become a member. And as always, thanks for watching, and until next time, peace.